Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we will be covering our last question on Euclidean geometry, which involves proportionality. Looking at this question, it gives us a diagram which seems to have quite a few lines and quite a few parallel lines, quite a few triangles. So let us read what other features they have given us indicated in the paragraph. So they tell us in the diagram below, ACH is a triangle with point B on AC and point G on AH such that BG is parallel to CH. F is a point on AH and D is a point on HC such that FD is parallel to AC. GB intersects FD at E. It is also given that HD to DC is 5 to 3, is in that ratio 5 to 3, and that AB is twice BC. Okay, and now they tell us AH, this whole length is 48 centimeters. Calculate the following with reasons. So the first length they want us to calculate is HF. And if we look at HF exists on the left hand side of the larger triangle, and we see this larger triangle HF, the side is joined to this side of the triangle by these two parallel lines. So HF corresponds to this side here, AF corresponds to this side here, and AH corresponds to this whole side here. So given the fact that we have the length of AH and we have the ratios of DH, CD, and therefore we can get the ratio of this whole side, we can therefore use proportionality within this large triangle to calculate HF. So let us go ahead and do that. So 10.2.1, we have HF, which is the side we want, HF divided by the entire length, since we are given that value, AH is equal to HD or DH divided by HC. We don't know the value of HF, we are trying to calculate it. The value of AH is 48. But before we continue, I just want to state the reason that we use the reason proportionality theorem or purport theorem. And whenever using purport theorem, you must state your parallel line, so that is FD is parallel to AC. Okay, so you can only state that two sides or two pairs of sides are in proportion, HF all over AH, HD all over HC, due to the proportionality theorem, which exists because of parallel lines. And then the ratio of HD to HC, we are given that HD to DC is 5 to 3, therefore HD is 5, and HC is a combination of HD plus DC, so it will be 5 all over 8, which is, we get 8 from 5 plus 3. And then making HF the subject of our formula, we get HF to be 30 centimeters. Okay, looking at 10.2.2, it asks us to calculate the length of FG. FG is the small length here. Now notice how FG doesn't correspond to a full length of any triangle as we saw with HF. It corresponds to this length GE, but we are not given the ratios of GE and EB, so we cannot use that triangle. So what we will do is we will, in fact, instead of looking across to the right this way, we will look downwards this way. So HG corresponds to that length BC and AG corresponds to that length AB. And the reason it corresponds is because those two lines are parallel, so we can use proportionality theorem within that triangle there, this large triangle, and looking downwards across these two parallel lines. Okay, so we know that due to the fact that HF is 30 centimeters, as we've solved, so that length is 30 and the whole length is 48 centimeters, we can then get the length of AF to be 18 centimeters. So 10.2.2, we get AF to be 18 centimeters. Okay, and looking at this triangle, we were given that AB is twice BC, so we have to, if we rearrange that and write it as AB all over BC, we will get that to be 2 over 1. And AB all over BC, we said will correspond to AG all over GH. AG divided by GH, and the reason there will be, again, purport theorem, and we have to state our parallel lines as usual, so that will be GB being parallel to CH. Okay, now that we have stated that, we know that AB divided by BC is 2 over 1. Now we don't have the length of AG, but we can write it in terms of AF and FG. And why does that help? Because we want to calculate FG, and we have the length of AF. So AG is equal to AF plus FG, and GH, although we don't have that length either, that is simply HF, which we calculated, minus FG. So HF minus FG. And we can substitute those two lengths since we have the values, and our only unknown will be FG. So that corresponds to 2 divided by 1 equals AF, we said was 18, plus FG divided by 30, which was HF minus FG. And when making FG the subject of our formula, we get FG to be 14 centimeters. Okay. Lastly, for 2 marks, 10.2.3, it asks us to calculate the ratio of EF to ED. EF being that length there, and ED being that length there. So again, we're going to be using proportionality, and looking at EF and ED, we see that it corresponds to, within the smaller triangle here, FDH. That smaller triangle has proportionality within it. Why? Because GE and HD are parallel. So FE divided by ED will correspond to FG divided by GH. So EF, so that's 10.2.3, 10.2.3. So we have EF. Remember, EF to ED is the same as writing it like this here as a ratio, EF divided by ED. And that will equal to GF divided by, we said it was GH. So EF divided by ED is equal to GF divided by GH. And we knew, well, we calculated GF to be 14, and GH will be HF minus FG. So HF is 30 minus FG, which is 14. 30 minus 14, and that leaves us with a ratio of 7 to 8. And we have solved for the ratio EF to ED. Alright, that brings us to the end of this question and to the end of our past paper analysis of Euclidean geometry. Thank you for watching.